Hi, I am Carlos Pinilla. I am answering the questions for the AI engineer role. So, on the first question, what is the difference between supervised learning, unsupervised learning, and reinforcement learning? So, in supervised learning, you have a set of data with some labels. So, you have this your independent variables and the dependent variable. So the dependent variable can be a class or it could be a number. So, a class for a classification and a number for a regression problem. In a unsupervised learning, you just have just a bunch of data, and you find the clusters for, or you could also do dimensionality reduction. You want to find the dimensions that best describe your data if it is highly dimensional, your data. Or you could do also anomaly detection to find outliers and perhaps you would like to reduce them. This type of algorithms are usually used together with some other components along the pipeline. So this one is just like a little piece. Um, Reinforcement learning happens when you have an agent that interacts with an environment, and the environment is dynamic. So you you know what are good actions or bad actions. You can classify them, so you can get the agent a reward or a punishment depending on whether what the agent what did was good or bad. And that is reinforcement learning. It is used in a dynamic environment when you don't know for sure uh, how it behaves. Um, on the second question, what is how can you deal with overfitting in machine learning models? So, well, first you have to recognize that overfitting is happening, and this happens when you have a way too complex model to fit to your data, so that the model just learns the patterns in the scene examples, so the data that it was trained on, but it has difficulties generalizing to unseen data. And a signal for this is when the metrics behave differently within your training set than with respect to the test set. So a way to avoid this is that you could have regularization techniques such as L1 regularization, L2 regularization. You could also add a dropout if you have a neural network, or you could do data augmentation. That is that you have your data. For instance, you're training a classifier, trying to classify images, and you augment your data by making deformations on your data. So you say that this class is not going to be changed if you rotate your image, or perhaps it doesn't change if you reflect it. So you could implement these techniques to have more data and try to reduce overfitting. Another technique is to use ensemble models. Ensemble models are usually less prone to overfitting. Um, and the next question is when have I used PyTorch or sklearn? I used PyTorch in the developing of a classifier for multivariate time series. This one consisted of a transformer architecture, and I also developed a gradient boosting neural network. So this one consisted of a gradient boosting with base neural network, an LSTM, and also another one with a base neural network, GRU. The one with a GRU had a less training time. Um, uh, I have used sklearn for K-means neighbors. This one was used in the network of entities and transactions within them to to recognize pattern and try to predict new possible relationships. And also in the pharmacovigilance project, So this one would look at a patient at a particular adverse event, and it would use the demographic data on the patient to try to predict if the reported adverse event was usual or unusual given the conditions on the patient. Um, so on the next question, that is, how would you deploy a machine learning model to production? Well, one first thing is that you have to make sure that your code is always backwards compatible. So that means that if you have a component that depends on several other pieces, if you change one little piece, you don't have to change all the way up the dependencies. So if you change just this little piece, you just change that. So you have to make sure that this is accomplished. You also have to make sure that um, that is modular. So that means that the functions within the code are separated. So that what this little piece is in charge of doing this function, this other component is in part of doing something different, and this is in part of doing something else. So if something breaks, and you can recognize what is going wrong, you only need to focus on the particular piece. Um, Something that we should be mindful of is also to be prepared to scale your data. So the not scale your data. So you have to scale the model so that if more queries are coming, or the data the data is changing, and you have to handle bigger volumes, so so that you're prepared for making those changes, and making these changes is not gonna just break the whole thing and you have to redo it all, but you can make it adjustable. And also something else that you have to document well all the code, and put a descriptive names on the variables, and put a descriptive comments, so that if you come back to look it later, you know what was going through your mind at the time that you wrote the code, or if someone else comes in, this person understands what they're seeing. Um, so in the next question, how do you handle noisy data? Well, first you have to recognize what is noisy data. So one good advice is always to visualize. So if you have data, you have to make sure that there's a way that you can get an insight of the data that you're dealing with. So visualizing is a good approach to get that feeling, because you can look at the distribution of the data, and if that doesn't look right with some base knowledge, depending on the particular case that you're dealing with, and then you can see, well, this is some data that has some issues. So visualizing is one tool for recognizing that, and with a dimensionality reduction, you can deal with data that there is noisy. If the particular feature where the data is noisy um, is can be discarded through the dimensionality reduction, then you go ahead and do that. Or you could also input variables. You could change with the mean or the average. Those are some tools that you could use. And some personal projects that I have worked on the last question is that I developed a standalone web page that will show um, the mammals periodic table. So this one was like a periodic table of, like, as the periodic table of elements, but it's as instead of elements it would have mammals. This was done in a collaboration with a cousin of mine that is a great graphical designer, and he had these great drawings of mammals. So the mammals would be grouped in terms of genera, families, and then you would click on a particular mammal, and it would show where does the animal live, what does he eat, some interesting facts. Some other application that I developed was a graph of principal routes in Colombia with the showing the traffic, like the volume. and the toll stations. And alongside it, you could also click on a toll station and it would depict all the nearby businesses. I did this with some web scraping and with the Google API to know what businesses were close by. And another app that I have in mind is picture a picture resolution enhancer. So that is that it uses generative AI to enhance the resolution of a picture. And that's it. Thank you.